When we look at a modern cargo ship, what we usually see is pure power. Steel, engines, and immense mechanical force carrying the weight of global trade. For much of its history, the industry operated on that premise, crossing oceans with only limited environmental oversight. Today, that era of leniency is decisively over. The oceans are now governed by a dense framework of international law, shaped by authorities such as the International Maritime Organization. To understand how those laws actually work, we have to look beyond the bridge and descend into the lower compartments, where daylight fades into a maze of machinery, piping networks, and exhaust systems. Hidden within these spaces is an invisible layer of automated technology. A cargo ship is not just a machine, it is a tightly regulated legal entity, and this interconnected network exists for one explicit reason: to prove the vessel has the right to sail at all. One of the largest hidden systems on board manages ballast water. Ships must take in enormous volumes of seawater directly into their hulls to remain stable during loading operations and ocean transit. This animated map reveals the serious ecological threat created by that process. When a vessel takes on seawater in one region and discharges it in another, it can release microorganisms, larvae, and invasive aquatic species into ecosystems with no natural defense against them. To neutralize these biological threats, ships are now required to operate a complex safeguard known as a ballast water management system. Inside the treatment unit, seawater moves through an automated sequence of filtration screens and ultraviolet irradiation chambers. These systems actively destroy foreign microorganisms before the water is discharged from the hull. This internal water treatment plant has nothing to do with propulsion. It exists entirely to protect marine biodiversity and secure the vessel's legal access to international ports. Further up the ship, inside the dense machinery of the engine room and exhaust trunks, the focus shifts from water to air. Under the MARPOL Annex VI Convention, international law imposes strict limits on atmospheric pollution from shipping, specifically targeting sulfur oxides and other harmful emissions. Looking at this real-time data graph, we can see how exhaust gas cleaning systems, or scrubbers, manage those limits. These are active compliance systems, continuously monitoring exhaust output and adjusting operations in real time to keep emissions safely below the legal threshold. And then there is the safety layer. Protecting human life at sea has always been a maritime imperative, once addressed primarily through lifeboats and basic emergency gear. Today, the modern implementation of the Safety of Life at Sea Convention is far more demanding. Bridge officers now oversee a continuous monitoring network of smoke detectors, heat sensors, and automated fire suppression logic distributed across the entire vessel. These integrated systems are mandatory lifelines. They respond faster than human perception alone, buying the crew critical minutes that can determine whether an incident is contained early or escalates into catastrophic loss. International regulations written on paper mean very little without physical enforcement. A ship must continuously prove that its equipment actually works. That proof is audited through a process known as port state control, in which external authorities board the vessel at the dock and carry out rigorous inspections. The inspectors demand evidence. They test alarms, review maintenance logs, examine calibration records, and verify that the crew knows exactly how to operate the machinery. This creates a significant operational vulnerability. Sensitive compliance technology must function flawlessly while surviving one of the harshest operating environments on Earth. Constant exposure to salt, extreme heat, moisture, and relentless vibration degrades components quickly. An emission sensor may drift out of calibration, or a heat detector may fail silently in a cramped machinery space. When those technical faults are discovered during an inspection, the commercial consequences can be severe. A single failed sensor can trigger official warnings, heavy fines, or even the detention of a billion-dollar supply chain right at the dock. In the end, the burden of the law falls on the people on board. The crew must perform daily maintenance, troubleshoot sensitive electronics, and document every action to keep these invisible systems alive. Because without them, modern maritime engineering no longer has permission to operate.